Hi everyone, I'm Lakehouse, an analytics engineer focused in data, AI, and automation. Today we will be diving into my next project, which is predictive intelligence system in healthcare that uses ML to predict hospital readmissions before they are going to happen. So this is very interesting because I built the entire framework starting from ingestion of the data till the predictive analysis using Databricks platform. So let's dive into the project. Okay, here comes the problem. We have 20% of the patients getting readmitted into a hospital within 30 days. This particular scenario is costing almost 26 billion US dollars every year. And we have to devise an end-to-end ML solution on Databricks that predicts the risk and enables proactive intervention. And the dataset that we have included in the project is from Kaggle, which has at least 100,000 rows of entries. So we are doing a large scale data transformation, finding insights into it with the help of ML. Okay, how is it different from other projects? We should have a unique selling point, right? Yes, we have it. We are moving from reactive stance to proactive stance. Traditionally, the descriptive analysis is more of looking backward. How many readmissions happened last month? How many of them were critical? But this reactive stance is very too late to help. So we are moving the stance to predictive analysis, which is more of looking forward. Who will be readmitted next? And this particular proactive stance enables early intervention, optimizes resource to high risk patients. This shift will also help in core innovation on what will happen instead of what happened. Okay, here comes the actual architecture of a project. A traditional Lakehouse architecture will have a raw data, three layers, which are bronze, silver, and gold layer, followed by actionable dashboards or any kind of insights that we are deriving from. So the entire journey, starting from raw data till the end of the dashboard, is a traditional Lakehouse architecture. What is different in our project is the inclusion of this ML workflow, which predicts the future possibility based on the features that we are going to devise upon. So what are the three layers, especially bronze, silver, gold? So bronze layer is the one that is used for raw data ingestion. And we have all the data into it. We don't matter about the duplicates or any kind of scenario. Silver layer is where we do the data cleaning, validation, and feature engineering. And we have an ML ready gold layer, which we are using for business aggregation and for dashboards. Okay, now we have to evaluate which model suits our use case. We have several models and we are not going into the deep learning model or the logistic regression model simply because deep learning models are too complex and will be considered as a black box, whereas the logistic regression model is the linear model which cannot interpret the non-linear relationship between the patients. And we have selected two models for this evaluation, which is the random forest model and gradient boosted trees. The random forest model gave a score of 0.6384, whereas the GPT model provided a score of 0.6402. So what is the score, AUC score? AUC is a term which is used for predicting the performance of a model, which is area under curve, which we will discuss in the upcoming slides. Okay, after selecting the model, we have one more validation to do, which is the ROC curve value. ROC stands for Receiver Operator Curve. It simply says how good is the model performing. The blue lines is the zone where it's making random guesses and it's mentioned as random classifier. And if the line is too closer to this particular point, we can tell that the model is performing very good. For the particular GPT model, which is the yellow colored line, we are slightly performing better than the random, which is actually good. We are performing at 0.640 compared to 0.5, which is the random guess. So we will proceed with the same model in our upcoming scenario. Okay, what are the other models that we have and why do we not select those things? As discussed earlier, the logistic regression, which cannot handle the nonlinear relationship, deep learning, which is too complex and we cannot predict or interpret what is happening there, support vector missions, which is difficult to scale and tune, K nearest neighbors, which is slow at performance, and naive Bayes, which is having independence, unrealistic independence. So we cannot use this particular or any of these models for a particular use case. So we will go with the GPT model and we will make the predictions. Generally, we have a misconception that the elder ones are the most at the risk for hospitals, but this is not true as per the particular data set. We have drafted a future importance chart and it shows that the one who received more number of medications are going to be at the risk of readmission, followed by the number of persons who stayed more in the hospital, followed by the ones who has been as an inpatient for number of times. So these three were the top three features, and this shows that age is not the predominant factor in deciding the risk that we are going to obtain. Okay, this is the actual dashboard that we are waiting for, and this is also where the prediction becomes an action. There are four risk categories that the model has identified, starting with critical, which has a score of more than zero point 0.7, which means they need urgent intervention, intensive call management, and the home remediation. Next comes the high category, which has a score of zero point 0.5 to 0.69, which means we have to plan for enhanced discharge planning, plan for the weekly calls, and they have 14% of actual readmission rate. And next comes the medium category, who comes under a score of zero point 0.3 to 0.49, and they have the standard protocols plus education materials, which will keep them at 10% of the actual readmission rate. And the last category, which is the low, they have less than zero point 0.3 of the score, and routine care minimal intervention is enough for them, and they will be with the 6% of actual readmission rate. So this dashboard not only features this, but also the risk scores of each of them. It filters by age, by department, by surgical team, and special intervention is recommended for those at critical risks. And we are going to validate that with actual outcomes and prove how the system works. What impact is it going to make? Care managers, especially the doctors, exactly know what to do. Predictions integrated into their daily workflow, they are going to save at least 12.75 million rupee, and they are going to help more than 1,000 patients. We all have a question, right? Will it work good? Will it perform bad? So this is where governance and reproducibility of an ML flow comes. So we are using an experiment tracking mechanism which is inside the Databricks that tracks each and every training logs, hyperparameters, metrics, and model artifacts. And it can reproduce any environment given that we have the dataset ready. It also enables the model versioning. For example, you may have a feature to be included in the next model, which you can do. And it provides the full auditability, which means the data, incoming data, features we have created, the model and the predictions it has made, everything can be audited. And it also satisfies FDA, HIPAA and CMS compliances and can predict any such kind of inferences. So this transforms an ML model, which are generally referred as black models, to auditable models. Okay, is the model good and future proof? Yes, it is. The entire architecture that we have developed can handle the future demands too, which means it's scalable. It helps the clinical person to understand and tell why it has flagged a particular person in the high risk category, making it explainable. And third, we can integrate this model into the daily workflows, making it actionable, saving money from the day one. What it means to business? It saves around $12.75 million by preventing 1,275 patients from the 15% readmission reduction, which means that we are going to save 1,275 patients from the further hospitalization, surgical complications, and medical adherence. Thus, this model proves that predictive intelligence in healthcare is achievable today. Thank you for watching this project. Connect with me in LinkedIn or YouTube. Happy to answer your questions about the technical implementation or healthcare AI applications.